Hello everyone, welcome to Discrete Learning Institute. You are all very welcome. Okay, so in today's class we're going to look at different questions in your preparation of your test 2. Okay, so our first question for today, it is saying that express as a single logarithm. Okay, we have 2 log 4, then open brackets 2x plus 3, close brackets, then minus log 4x minus log 4, 2x minus 1. Okay, so this is a logarithmic what? Expression. So they want us to represent it as what? As a single logarithm. Okay, so what you do is this. Okay, so what you do is this. So you have been given 2 log 4 2x plus 3, okay, minus log 4 x minus log 4 2x minus 1. Okay, so this is the logarithmic expression that we have been given, and they want us to represent it as what? As a single log. So for us to represent it as a single log, we need to have the same base here at the bottom. Okay, we need to have the same base. So looking at the way this is, we have the same base for all of these logarithms. You can check here, it is base 4, here again it is base 4, here again it is base 4. So here we can combine these, but we cannot combine them if they have these numbers which are in front. Okay, so we know that in logarithms these 2 can come back here because that's where it was initially. So it can come back there, or it can go back there. Okay, so here if you were to write this again, you're going to say that this is the same as the 2 comes here. You're going to say that it's going to be log 4 2x plus 3, then the 2 comes here, then it's going to be minus log 4 x minus log base 4 2x minus 1. So after writing this, since they all have the same base 4, you can just write it as log base 4, then you open brackets. Now you start combining these solutions. Okay, the 2x plus 3 to the power 2, you write it because it's positive here, right? So meaning that if it's positive, meaning that it's on top. Okay, so it is 2x plus 3 squared. Okay, then if it is minus, it is in the division. Okay, so meaning that it is minus log x. So you get the x, you put it here at the bottom. Then here again it is minus log 4 2x minus 1. So meaning that the 2x minus 1, which is in brackets, is going to be in the denominator. Okay, that is what it just means. So the only thing now you can do here is just to simplify this. You're going to have log 4, then here you're going to have 2x times 2x, because since this one is the same as it's going to be 4x squared plus 12x plus 9 on top, over at the bottom you're going to have 2x squared minus x, and that will be your answer. Are we together?
We can't see your screen, sir, so I don't know if we're together, but we can hear whatever you are saying.
Alright. Alright, so it's just the network, but others are able to see. So let us continue. So that is the answer. Is everyone clear? So you're free to respond, those who are able to see the screen.
Kindly repeat, sir.
Oh, okay. So when you're solving, they give you to say that express this expression, logarithmic expression, in the form as a single logarithm. So the first thing you need to understand is that for you to express as a single logarithm, you need to have the same base. Okay, so looking at all these logarithms that are here on top here, you can check them out. They all have what? They all have the base 4. So meaning that there is no need of changing the base on any. Okay, so now since there's no need of changing the base, we come now to since we have to put it as a single logarithm, we don't need to have numbers in front of these what? These numbers. But just a minute. I've received a phone call. Okay. So I was explaining to say that since we have to change this to become a single logarithm, we don't need to have these numbers. Okay, the 2 is not supposed to be in front, it has to come back so that we can just have log without any number in front like this. Okay, so we took back the 2 this side, it came here, so it became log 4, and then the 2 came here, it became squared. Okay, because that is where it was initially. So now after that we just get the log 4. Okay, we just get 1. Since all of them they are the same, so you just get 1, you say log 4, then you open brackets, then this one, since it is positive, meaning that it is on the numerator side, so meaning that if it's positive, meaning it's going to be 2x plus what? Plus 3, then together with a square, which is here. Okay, over this side it's minus log x. What you're only focusing on, because the log 4 you've already written it, it's here, so you're focusing only on the x side. Okay, so you only have x, so you get the x, you write it here. Okay, then it's minus log 4 2x minus 1, so you only get the what? The 2x minus 1 and put it here. Okay, then now you just do the normal calculations of expanding. Even here you expand, as a result you're going to have this answer which is here. You just leave it like this. Are we together? Okay, so we've solved this question. Everyone is clear on this one. Let us solve this other question. Okay, so question 2 says that hence solve the equation. So we have been given this equation. Okay, so on this equation that we have been given to say that this is 2 log 4 2x plus 3 is equals to 1 plus log 4 x, and then we have plus log 4 2x minus 1. Okay, so what I usually like to do is that if I have an equation here in logarithms, I take everything to be on one side. Okay, so that I can express it as a single logarithm, and after expressing it as a single logarithm, I am now going to do what? I am going to find the value of my x. Okay, so if you were to take this, okay, for example, if I leave the 1 in this case, because the way I'm seeing this question, if I leave the 1 here, I take this one this side, I'm going to have 2 log 4 2x plus 3. Okay, so I've taken the log 4x this side, it's going to be minus log 4x. Then again I take this log this other side, since all of them they have what? They have logs. Okay, again when I take it, it's going to be minus log 4 2x minus 1 is equals to 1. Now if you examine this very well, it looks the same as the first one which we had. Okay, And this entire thing can be expressed as a single log by just writing this, which is what? Which is here. Okay, so meaning that this entire thing which is here can just be expressed as a single log, and that single log is log base 4. Okay, then we have 4x squared plus 12x plus 9, okay, over 2x squared minus x. Okay, that is what we have as a single logarithm, and we are going to equate it to what? To 1. Now remember what I said. If you have a logarithm, to say that this is x is equals to log log a b, the a is the base, okay, and the x is the power, is equals to the solution. It is what? It is the b. So this is in an exponent form, and this one is in a logarithm form. So now, how can we change from a logarithm to an exponent? Because that is the simplest way we can solve this equation. So what you're going to do is that this is a base, this is a power, and this is the solution. So you're going to say that 4, which is the base, to the power 1, it is equivalent to 4x squared plus 12x plus 9 over 2x squared minus x. Okay, are we together, everyone here? So you can just unmute yourself. Are we together?
Yes, we are together.
All right. So since here we've expressed it in this form, it's an exponent form. We can get this one to be, so this one is going to be 4. Okay, so it's going to be 4 is equals to 4x squared plus 12x plus 9 over 2x squared minus x. Okay, I can cross multiply. The 4 is going to multiply with what is here. As a result, I'm going to have 4 multiplying with the 2x squared minus x is equivalent to this one is multiplying with what is on this side. As a result, I'm going to have 4x squared plus 12x plus 9. Okay, that's what I'm going to have. Then this side, I'm going to have 4 times 2x squared is going to be 8x squared. 4 times x is going to be minus 4x, is equivalent to 4x squared plus 12x plus 9. So now I have a normal equation. So I can take this one this side. I'm going to have 8x squared minus 4x squared. Okay, 4x squared, and then it's what's on this other side. Oh, sorry. The 8x squared, then this is positive 4x squared. I'm taking it this side, it's going to be minus 4x squared. Then I get the minus 4x. Then I get now the positive 12x comes this side, is going to be minus 12x. Then the 9 is going to come this side, is going to be minus 9 is equals to 0. Then 8x squared minus 4x squared, I'm going to have a 4x squared. Negative 4x minus 12x, I'm going to have a minus 16x minus a 9 is equals to 0. Okay, now what is my product? My product, I get it by multiplying this one, which is the number that is with the x squared, and the constant, which is negative 9. I'm going to get negative 36. Okay, then what is my sum? My sum is this number which is here. So as a result, I'm going to have negative 16. Now, what are my factors? Give me two numbers. When I multiply them, I am getting negative 36. When I add them, I am getting negative 16. Those two numbers are just negative 18 and a 2. Okay. So these are the two numbers. When I add them, I am getting negative 16. when I multiply them, I am getting a negative 36. So therefore, I'll say that this is, I'll write it the way it is. So this is 4x, so I'll say 4x squared. Now, where the sum was, I'm going to replace it with what? The factors. So I'll say minus 18x. Then the remaining one, it is positive. So I'll say it will be plus 2. Then I just add the x. Then minus 9 is equals to 0. So this side, what is common? What is common on these two? It is the 2x. Open brackets. 2x into 4x squared is going to be 2x. 2x into negative 18x, it's going to be minus 9. This side, what is common? It is 1. 1 into 2x, it is 2x. 1 into negative 9 is going to be minus 9 is equals to 0. Then this side, I'll get the 2x plus 1, and I'll also get the 2x minus 9, and I'll say it's equals to what? To 0, because these two are equal, so I'll just get one of them. Therefore, I'm going to have x, this one, I'm going to have 2x plus 1 is equals to 0, and I'm also going to have 2x minus 9 is equals to 0. Okay, therefore, for the first solution, I'm going to have from here, I'm going to say x is equals to negative 1 over 2. Then this other side, I'm going to have x being equals to 9 over 2. Okay, which is positive. So, these are the two solutions that I've gotten for x. Now, when I'm dealing with logarithms, I just don't get my answer the way I've gotten it. I have to test my solutions on the original equation. So the original equation is this one, and I have gotten a value which is negative half, and what? I have gotten negative half and positive 9 over 2. Okay, so the key thing in a logarithm is that in here I'm not supposed to get what? I'm not supposed to get a negative value or a 0. Once I get a negative value in this or a 0, it makes that solution to become invalid. Okay, are we together? Is everyone there? So you just give me, just unmute yourself and respond, because I'm not able to see the thumbs up if you're giving thumbs up.
Yes, sir.
All right.
Yes, sir.
Yes, sir.
All right. So now let us test those two solutions. So when I plug in negative half here on x, I plug in negative half, I'm going to get negative 1 here. Okay, I'll get negative 1 on this part. Then negative 1 plus 3, it will be positive 2. So in here I have a 2. Then when I come here, this side, when I plug in negative half here, because this one when I plug in negative half, it's going to have a negative in a log, and that is not acceptable. So because it's not acceptable, even on 1, if that solution is not accepting, even on 1, you make that solution to become what? Invalid. Now let us get the 9 over 2. When we plug it in here, we are going to get a 9 plus 3, that will be a 12. Then here we are going to get a 9 over 2. Then here we are going to get 2 times, that's going to be 9 minus 1, which will be an 8. So because of it's giving you a solution, okay? Because it is giving you a solution, that one, it means that here we are going to say that x equals to negative 1 over 2 is not a solution. Therefore, our x is equals to 9 over 2. And you're done with this question. Any question? Any clarification? You are free to ask. Okay, so if there's no question, we continue. Now, here we have been given this question. Yes, you're free to ask. Yes, the one who's just from saying something. You're free to ask your question. Maybe you want me to clarify it somewhere. You're free to tell me. Okay. Let us continue. So now, this is another question. This is on limits. It's saying that evaluate each of the following limits. Okay, so we have the first limit. It's saying that limit as x approaches what? Approaches 2. Okay, so as x is approaching 2, we have what? We have a limit. Okay, so now in this case, when x is approaching 2, so I'll say I. So the limit as x approaches 2, for this case we have x squared minus 4 over x to the power 3 minus 8. Okay, so now when you are supposed to solve this, we know that the easiest way of solving limits is you just plugging in the 2. You're going to say that the limit you just plug in here. You're going to say that the limit as x approaches 2 is going to be 2 squared. You plug in the x with a 2 minus 4 over 2 to the power 3 minus 8. And this will give us a 4, okay, minus 4 over 8 minus 8, and this is going to give us 0 over 0. Now, looking at what it has given us, can this be defined? No, this is what? Undefined. So, if this is undefined, you need to modify this equation in such a way that you remove every O that is there. Okay, so here there is a O. So, those two similar equations, or let me say similar equations, they have to do what? To cancel on the numerator and in the denominator. So in this case, if you are to factorize the one on top, you have limit as x approaches 2, you have x minus 2, because it's a difference of 2 squares, the one on top. And then you're going to have x plus 2. Then you factorize the one on top. Then at the bottom here, you have x to the power 3 minus 8. So x to the power 3 minus 8, it is a polynomial. Okay. It is a polynomial. So the same way we used to solve polynomials, okay, where we have to find a factor, we do the same thing even here. Okay, so for this case, let us plug in, this one is, let's plug in the 2. When we plug in 2 here, we are going to get a what? A 0. Okay, so meaning that x being equals to 2, it is a what? It is a factor. Okay, it is a factor. So meaning that our x minus 2 is our what? Is our factor. So we're going to say that here we have one of the factors, it is x minus 2. Then now, what other equation are you going to write here? You use synthetic division to come up with a new equation. Okay, so now if you check this very well, you have x to the power 3 minus 8. what are the other variables that are missing? You have x to the power 3, and then you're going to say plus 0x to the power 2, then plus 0x plus the 8. So these are the missing variables that are not there. So you're going to rewrite it like this, so that when you're getting the coefficients, you're going to get a 1, a 0, and an 8. That is what you're going to put here. Okay. Then, what is our factor? Our factor is x minus 2, meaning that it is the same as x is equals to what? To 2. So, meaning that our factor is 2 here. Then now, you drop the 1. Then you say 1 times 2, it will be a 2. 0 plus 2, it will be a 2. 2 times 2, it will be what? It will be a 4. You add it here. You put it here. 0 plus 4, it will be a 4. 4 times 2, it will be what? It will be an 8. 8 minus 8, it's going to be... Oh, this one is negative 8, sorry. This is minus 8, okay. So you add a negative 8 there. So it's going to be a 0. So because it has given you, assuming that the remaining numbers now which are there, it is this one. So check the highest degree here. It is x to the power what? X to the power 3. So meaning that the next degree is going to be what? X. So meaning that here it is 1x to the power 2. Then this one it is plus 2x. Then this one it is plus 4, which is just the same as x squared plus 2x plus 4. So this is the new equation that will remain after we have gotten this factor. Are we together? Was I too quick?
Yes, sir, you are too quick. I did where you found the fact in the denominator x minus 2. Then it was beautiful mistake by after you said x to the power 3 minus 8 is a polynomial. Then from there it's breaking.
Oh, okay. But now you're able to get me clearly, so that I will explain.
Yes.
All right. So now, what I was saying is that here on top, it is easy to factorize, right? It is a difference of what? Of 2 squares. So we just said it is x minus 2, x plus 2. But the one at the bottom, you just don't say that x minus 2, then you say x squared minus 4. No, that is totally wrong. Okay. So what you're supposed to do, because this is a polynomial, check the degree. It is power 3. Okay. So in other ways, this one can be written as x to the power 3 plus 0x to the power 2 plus 0x, then plus, oh, so it's negative, that one, minus 8. Okay, so this is the complete polynomial. So now the first thing that we do, it is to find a factor. Now remember, when we had plugged in the same 2, which is here, we got a 0 in the denominator, right? That one is telling us that it is a what? It is a factor. So x minus 2. So since we say that it is x is equals to 2, meaning that when the 2 comes this side, it's going to be x minus what? Minus 2. Meaning that x minus 2 is our factor. Clear here?
Yes, sir. Yes.
All right. So I wrote my x minus 2 here. Then now, after I did that, since in synthetic division, I use the number, not the x minus 2. Unless if I was doing the long division method. That's when I'm going to use the x minus 2. But since I'm using synthetic division, I'll just get the 2. So it will be x minus 2 is equals to 0, meaning that x is equals to what? To 2. So I'll get the 2 and I'll add it here. Now, this function which I had in the denominator, x to the power 3 minus 8, the other way you can write it, it is like this. Okay? And it is the one which will work well for a synthetic division. So here I am going to get the x to the power 3 plus 0x squared, because in synthetic division, the degrees have to follow each other in decreasing order of 1. So if here it is x to the power 3, meaning that the next one is supposed to be x to the power 2, then plus 0x minus 8. Okay, so now my concern, it is to get the coefficients. So I'll get the coefficients from this expression. That is a 1 in front, then here I have a 0, then here I have a 0, then here I have a negative 8. These are the coefficients which I am going to use in what? In synthetic division, as I wrote like that. Are we together up to this point?
Yes, sir.
Okay. So after I did that, I now started using synthetic division. I dropped the 1, it came here. Then I said 1 times 2, it gave me a 2. 0 plus 2, it gave me a 2. Then again, the 2 which I found, 2 times 2, it gave me a 4. 0 plus 4, it is a 4. 4 times 2, it is what? 8. Negative 8 plus 8, it would be what? A 0. Okay. So because it has given me a 0, it has clarified that this is what? It is a factor indeed. Now, the remaining numbers that I have here, they are the ones which I'm going to now express this expression of x on. Now, the highest degree here was x to the power 3, meaning that after I divide a factor in it, I'm going to remain with what? A lower degree than what I had previously. So since I had x to the power 3, meaning that what I'll get, this one which is in front here, it will be x to the power what? Power 2, which is what I wrote here. Then this one will have x. Then this one will be a constant as it is like this. Are we together? Is it clear?
Yes.
Okay. So now this is now what I got, and I multiply. I added it here. So me adding it there, it just tells me that I still have the x to the power 3 minus 8, because when I multiply this and this, it will give me this again. Okay. So I have now used, so that's what you're supposed to be doing if you're given such a question like that one. Okay. So you just have to be very careful with your calculations so that you don't make mistakes. Okay. So after you reach this point, you're going to cancel the common terms like this one, and this one will cancel. Then you're going to have limit as x approaches 2. It's going to be x plus 2 over x squared plus 2x plus 4. Then now, you can now plug in the 2. Okay? Because now you've removed that one. So it's going to be equals to 2 plus 2 over 2 squared plus 2 plus 4. As a result, it's going to be equals to 4 on top. Here at the bottom is going to be 4 plus 4 plus 4. As a result, to be 4 over 12. And this will be equals to 1 over 3. Clear?
Yes.
Okay. Wonderful. So that's how you solve this question. So sometimes you can put this on top, sometimes you can put it down. That doesn't matter. Okay. The key thing is you solving. You don't have to have 0 over 0, because this one is telling you that that's undefined. Okay, it cannot be expressed. Okay, So now let us continue. 2. So we have a limit as x approaches what? Infinity. So this limit, we have been given 3x to the power 3, okay, plus 5.
Sir,
Yes.
I'm sorry to take you back. What if the numerator is the one which has got a 0, then down, or let's say denominator is a value, let's say 1, then you divide.
Or like the numerator is 0 over 1, like this.
Yes.
Now this one is divisible. This would give you 1. But what doesn't work
Okay.
only, it is when it is like this. This one is undefined.
Okay, sir, thank you.
Welcome. So if it is 0 over 1, it is just 0. Okay.
Okay, sir.
All right. So then now the other one is 5 minus x squared minus 3x to the power 3. Okay. So now that's what I have. So now you need to realize this thing. Okay. When you have 1 over x. When you have 1 over x, this one is what? It is how can I say it? This one, it is let's talk about this one for, it's a rational function, right? So if you try to sketch this one as a rational function, you're going to have this. This one will be your vertical asymptote. Okay. Then your horizontal asymptote is also going to be what? To be 0. Okay. So why is it 0? Because there is a difference of 1 between this, the numerator and the denominator. Okay, in degrees. This one is x to the power 0. This one is x to the power 1. Okay. So this one is greater than this one. So meaning that the degree is what? Is 1. I want to explain something here. I'm not explaining about rational functions here. Okay. So now if I try, if I'm sketching for 1 over x, I'll start testing. This one is from negative infinity, positive infinity. Okay. So let us see how this function will be behaving when we start adding what? We start plugging in values that let me say is to infinity, right? So when I start plugging in oh, sorry. Let me say this one. Okay, x squared, 1 over x squared. So you find out that when I plug in a negative value, right, as x approaches infinity from the negative side. So if I plug in a negative value, I'll get a value that will be going this direction like this. Again, this side, I'll get a similar value going this way. Okay, so now I'm seeing that as I'm approaching infinity on the negative side, I am getting what? I am getting closer and closer to what? To 0, but I'll never touch 0. That is one thing you're going to realize. Again, this side, when I just get this, okay, as I'm going to infinity on the positive from the positive side, oh, sorry, not to infinity, sorry, not this. It's here. Okay, I know it has to also come this side, but now we are focusing on the infinity because it's just infinity. So we are focusing as it's coming from the negative side and this side. Okay, as it's approaching what? Infinity. You are going to realize that this number will be getting closer to what? To 0. So because of this existence, you need to make sure that here what you have, the 1 over x squared, you express this one in such a way that you can just cancel out this 1 over x to the power 2 to become what? To become 0. So what you do is that you check which one is the highest degree. Okay, it is 3x to the power 3. So now you remove it out of this. Okay, when you remove it out, you're going to have, so here focus on the x alone. So you're going to say that limit as x approaches infinity, you just get the x to the power 3, you factor it out. When you factor it out, you're going to have a 3 on top. X to the power 3 into this is going to give you a 3. Then plus 5 over x to the power 3. Okay. Now, over, because this one is undefined, even if you plug in on the x here, it will be undefined. Okay? Because you don't know what it is. It's a symbol. Then here again, you remove the x to the power 3. Then you start dividing here. Okay? You start dividing. X to the power 3 into this, it will give you 5 over x to the power 3. This one will give you minus 1 over x. Then this one, okay, here it's going to give you minus 3. Okay, so after it does that, this and this will cancel. You're going to remain with limit as x approaches infinity to be what? 3 plus 5 over x to the power 3 over 5 over x to the power 3 minus 1 over x minus 3. So now you've seen these ones that have 1 over x, 5 over 3, as they are approaching infinity. These ones which have 5 over x to the power 3, 5 over x to the power 3, 1 over x, these ones, as they are approaching infinity, the number gets closer and closer to what? To 0. So because that is the case, you are going to say that the limit, it is equals to 3. Then this one which has the 5 over 3x is going to be plus 0 over, even here at the bottom is going to be 0 minus 0, then minus the 3. As a result, it's going to be 3 over negative 3, and the answer will be negative 1. Are we together?
Yes, sir.
Okay. So that is what you do for these ones. So just practice more.
So, sir,
Yes.
I have a question.
Yes.
What if the limit is when x is approaching negative infinity? We're supposed to use the same procedure, or what?
It's usually the same procedure mostly. It's just the same procedure. Yes. But I'll explain in the other class, the one for the negative. Okay. But for the one for the positive, that's what you do.
Sir.
Yes. Since this is just preparation for your test, let's just do it here. So now, don't know what time it is now. Okay, so it's 21:08. We still have some minutes. Otherwise, the disturbance came in at the start of the class. Okay, let us continue solving. This question is saying that given the function f of x is equals to 1 minus 2 sine 1 over 2x minus pi over 6. Find the amplitude, period, phase shift, vertical shift, and sketch its graph in the interval 0 to 2 pi. So this question altogether, if I was to calculate, it is about 6 marks. Okay, 3 marks for the sketch, 1 mark for each, the period, the amplitude, and the phase shift. Or 4 marks, so it's somewhere 7 marks. Okay, so now this is your function. 1 minus 2 sine 1 over 2x minus pi over 6. Okay, so remember last time when I was explaining this or for those who watched the video, I said that a normal function is usually like this. A, since there's sign, so let me put sign here. Sine bx plus c, okay? Bx plus c, then plus d outside. That is how it is, okay? So if you are to express this in this form, it's going to be f of x is equals to, so you've seen this, so that's why you're going to, so it's going to be negative 2 sine 1 over 2 x minus pi over 6. Then the 1, it's positive, so it's going to be plus 1 because that is the d. Now let us solve. So since we've arranged it in order now, following this general formula, we're going to say that our amplitude, what is our amplitude? Okay, amplitude. Our amplitude, we get it by saying it's the absolute value of A. So in this case, our A, it is negative 2. So it's going to be negative 2, the absolute value of it, which just to be what? A 2. So you found your amplitude, you get your 1 mark. Then now you go to the period. Period, it is equals to, since here we are using radian measure, it will be 2 pi over b. Okay, this will be equals to 2 pi. What is 2 pi? 2 pi, that is a radian measure. Then b, here what is our b? Our b, it is the number that is with the x, which is just 1 over 2. So I'll write 1 over 2 here. And it will be equals to 4 pi. And you get your other mark. Then now you go to the phase shift. For the phase shift, you equate what is in the brackets here, okay, to 0. So it will be 1 over 2 x minus pi over 6 is equals to what? To 0. Then you take this one, this side, it's going to be 1 over 2 x is equals to pi over 6. Then you divide the half, even this side the half, it is going to give you x will be equals to, so since you've divided the half, or let me just take it this side here, I'm going to have 1 over 2 x is equals to pi over 6. You divide by the half, you divide by the half. As a result, your x is going to be equals to pi over 6 times 2 over 1. Okay, and your x is going to be equals to pi over 3. And this is your phase shift. Okay, are we together? Before I move any further, is it clear, everyone?
Yes, sir.
All right, wonderful.
Yes.
So this question, they bring it, make sure that you get it correct, because it's coming even in the exam. Okay, they like bringing it. Okay, questions like this, not necessarily like the same, no, but questions like this, I like them. Okay, so after you've solved your phase shift, what is your vertical shift? For your vertical shift, you need to realize that your vertical shift is just this one, the d. Vertical shift is equals to what? To d. In this case, our d, it is plus what? Plus 1, meaning that our vertical shift, it is what? It is 1. So now on vertical shift, you say if it's positive, you say 1 upward. Okay, if it's negative, you say 1 downward, or you can say positive 1. So it's moving upward by 1. Okay, that's how the sketch is going to what? To move. Okay, so after doing that, now let us now sketch.
So a bit behind on where you got the 1.
Okay. Okay, let me explain it. So where we got the 1 from, you've seen this this function.
Yes.
It has a 1 here, right? So this one, you've seen it, right? I said that we are rewriting this function here in this form. Okay, so since this 1, we know that this 1 is a D, but it has just been placed in front. Okay, it has just been placed in front. So we are arranging it in such a way that it looks the same way as it was originally. So we've written it again. We've said that it is -2 sine. So we've just, so the 1 has gone this side. So it has become -2 sine 1 over 2x minus pi over 6. Close brackets. Then now you're going to be plus 1. The 1 has gone the other side now. So it is plus 1 here. It's still plus 1. You've seen it? Are you there? The one who asked the question.
Yes, I'm here.
Okay. So it's +1 there. So now this +1 is representing D. Here. Now our vertical shift, it is equals to D, regardless of the sign that it has. So if it is +1, like what we have there, it is positive what? +1. You can write 1 upward, like what we did. So meaning that it is moving 1 unit up. So I'll write 1 upward. If it's negative, you write -1, or you say 1 downward. Clear?
Clear.
All right.
Thank you.
Welcome. So now let us sketch this graph in the intervals that have been specified. So they've said that the interval is from 0 to 2 pi. So this is just the same as saying 0 to what? To 360. Okay. Just that the other one is just in radian measure. Okay, so we focus on this one they've given us. Don't use degrees when they say use this. Okay. So now what do? You find the scale. The scale doesn't carry a mark, but it will help you to do what? To sketch. Okay. So scale is equals to period over 4. Then what is my period? My period, I got it to be what? 4 pi. So I'll come here and I'll write 4 pi over 4 is equals to pi. Now, what does the scale represent? A scale is representing a point on the graph. Okay? A point on the graph where it is critical, the graph is going to turn. So from 0 to pi, that is when this sine graph is going to make its first turn. Okay, that is what the scale tells us. That's why I am dividing by 4, because if you check the normal sine graph, it has 90, 180, 270 and the 360. So from here it will start going up. When just the 90, point number 1, it will turn. Here it will do this. Here it will do this. So these are the 4 critical points. That's why I'm dividing by 4. In the period, then a period, it is representing a complete cycle. So this is a complete cycle of a wave. Okay, a wave, that is a complete cycle. So when I say scale, I want to find those points where it is turning, and I've found out that for every pi unit, the graph does what? It changes. And we know that pi, it is what? It is 180. Okay. So those are the things that you need to do what? To note. Are we together on my explanation?
Yes, sir.
Yes, sir.
Okay. So what you're going to do now is that you have the sine graph. Okay, this is your sine graph. So this sine graph which you have, it has a normal sine graph. It is like this. So this is another important thing that you need to have. You have the normal sine graph which goes like this. Here there is 90, here there is 180, here there is 270, here there is 360 or 2 pi. Then here you have this is going to be 3 pi over 2, and this is pi, and this is pi over 2. Okay, that is what you have. So this one is in radian measure, this one is in degrees, like that. So this is the sine x graph. Okay, so now you are sketching this graph they've given you, and it is what? It is f of x is equals to -2 sine. This one here is going to be x. It's going to be 1 over 2 x minus pi over 6. Okay, then plus 1. That is our what? Our graph. Okay, so when you're sketching, you sketch it in parts. So if you have a pencil there with you, you do this. So I'll write with a black ink to show the main board. So you've seen that it's shifting by 1, so upward. So I'm going to give more space to the upward part. When I do this here, I'll write my line here so that I have more space on top, such that when it moves upward, I'm easily able to see that unit. Okay, so now I'm going to write my amplitude. My amplitude, it is the how high, the maximum limit, which is what? A 2, and the what? And the -2. Okay, and here we have a 0. Now the normal sine graph, and then now the scale is representing what? The points which are critical. So we have pi as our first one, and then we have 2 pi as our second one, and then we have what? 3 pi as our what? Third one, and we have 4 pi, until a complete cycle is what? Is made. Okay, that is, don't forget that. So now after you do this, the normal sine graph would have gone like this. Okay, from 0 it would have come here. Okay, when it reached the pi, it would have turned, reached this 2 pi, it would have reached there again, it would have gone like this, then until it touches there. That's how the normal sine graph in this case would have been. But now this is where the challenge comes in. This is when it is sine x, but here it is -2 sine. So because of this negative in front, okay, the negative will make this graph to do what? To bend. So you've seen that this is positive, so this point is positive, it will become negative. So this point will come down here, it will be inverted. It will be inverted. Then it will go like that. Oh, just write it properly. To come there, going like that. So now our first scribbling has saved its purpose. It was for us to have this inverted what? Inverted graph. So now after we have this inverted graph, you solve it in parts. Don't just go direct. No, it might give you challenges. So you solve it like this. So as you are sketching, the next step after you've inverted it, the next step is you go to the phase shift. Okay, so the phase shift, it is how much the graph it is moving either to the right or to the left. Okay, so this one, our phase shift was positive pi over 3. So meaning that it is moving to the positive side by pi over 3. So meaning that each point on this graph, you are going to be adding it by pi over 3. Okay. So here, you are going to add the pi over 3 on the 0. The point will change. So I'll use now the red ink. So this point moves. It's going to 0 plus pi over 3 is going to be pi over 3. So the point will be here. Okay. Let me... Here it will be pi over 3. Then this other critical point, which is here, you're going to add pi plus pi over 3. Pi plus pi over 3, it will be 3. And then it's going to be 4 pi over 3. So meaning that here it's going to be 4 pi over 3. Okay. And then here again, it's going to be 2 pi plus pi over 3, which will be 7 pi over 3. So even here, you're going to have a 7 pi over 3. Okay. Then here again, 3 pi, it's going to give you 10 pi over 3. Then here again, this point, it's going to give you what? It's going to give you 13 pi over 3. So now, that is how much it is being shifted to the what? To the right side. So this point has shifted to this point. So meaning that using the red ink, this point has moved. So meaning that here, it is now here. Then this one, which was here, it is now where? It is now here. This one, which was here, it is now here. This one, which was here, is now where? Is now here. This one, which was here, it is now here. As a result, you have now a new scribbling, which will be on this part. So the first, this one now has saved its purpose, so you can rub it off. It has now saved its purpose. So now you have a new graph. So that is where now your focus changes to. Then now, when you are now sketching the other part, now the next thing, it is an upward shift by what? By 1. Okay? So meaning that each point here, your focus, if it says by 1, meaning that this now it's in the y. Okay? So here now, here it was 0. When this point shifts upward by 1, it's going to come here where there is 1. So I'll write here 1, here -1. Okay, so if the 0 point shifts upward by 1, it's going to come where? It's going to come here. Okay, so it comes there. The other point, it's going to come, this point is here, is going to come where? Here. Then the other point, which is here, is going to go up here where the 1 is, because it was 0 plus 1, it will be 1. Then this one, it was on 2. So meaning that when it goes upward, it's going to go on what? On 3. So meaning that this point is going to come here on top. Then this point, it was on 0, is going to come where? On the 1. Okay. As a result, you now have a new graph which is going like this. Okay, are we together up to this point?
Yes.
Okay, so that is what you're going to have. So now, after identifying that this is what you're going to have, this one is not the actual answer which they want. Okay, mind you, it's not the answer which they want. Remember, they gave you a limit. So me, I was first solving it with every point. Okay. Oh, sorry. Okay, it's there. Okay, so now I can rub off this one. I didn't remove any limit here. I was just solving it if they didn't give me a limit. That's what I would solve it, and my answer would be what? Would be correct like this. Okay? But in this case, they've given me a limit to say that from 0 to 2 pi. So meaning that up to 2 pi, that's where my graph is going to do what? To end. So this side, I'm going to rub it off. So I'm going to end here. Then this side, because if it was here, it would have gone upwards. So meaning that here is going to continue like this. Like that. Okay. So that I can have the 0 also be what? Be part of this graph. So I'm going to have a graph going, starting from here, going this side, up to where? Up to here. That will be my graph. So this side, I'll rub it off. As a result, my final answer is just going to be this, which is here, which is just f of x is equals to -2 sine 1 over 2x minus pi over 6 plus 1. Are we together? Hello? Are we together, everyone?
Yes, sir.
Okay. So I didn't, the first thing that I'm supposed to do, I'm also supposed to focus on the limit that they gave me. But the reason why I solved it like this, because I wanted you to have the entire idea of what it's supposed to be. If I was just to go direct on this, you would have had that information. Okay. But I wanted you to show you everything what you do normally if they don't give you a limit. So sometimes they don't give a limit. So if they don't give you a limit, you can write it the way you had written, I had written it at the start. But if they give you a limit, follow that limit. Okay. And you'll be good to go with your sketching. So if you feel it is easier for you to start making a table of values, which I know is going to take you a lot of time, you can do that. Okay? But you can just sketch the way I was sketching without doing all those calculations to find the value of what? Of y on each point. Okay. Are we together? Is everyone still there?
Yes, sir.
Yes, sir. Please.
Okay. All right. So we're going to end here. So those are some other questions. Okay. Yeah. We'll continue. We're still solving. Okay. We are still solving. So I'll send the video.